శ్రవణ్ స్టార్ట్ చేసిన. హలో శ్రవణ్. హలో. Very good afternoon to one and all. So my name is Dr. Sandha Rajita, Assistant Professor in Dr. B.R. Ambedkar Open University, Geology Department. So now, today topic is the structural geology, right? So in this fifth semester, we have structural geology and economic geology is there, right? So now, what is structure? Structures means in different types of structures is there. Falls is there, folds is there, and joints is there, and also unconformity. So these are the main structures in the structural geology. So these are the very important topics, right? So you see in the block 1, unit 1, introduction is there and mechanical principles is there. Sorry. And also procedures. And third one is third unit, primary structures. In that we have sedimentary and igneous structures is there, right? So now, now we are going to the introduction briefly, that is the about the structural geology history, right? So you see here, Leonardo da Vinci. All of you know about this person. Leonardo da Vinci is an artist, right? So in the year of 1452 to 1519, he drew carefully shape of rock bodies in sketches to understand the natural shape of the earth. So in which year? 1452 to 1519, right? So perhaps the first description of the rock deformation came in which one? The 17th century. In 17th century by Nicholas Steno through the which principle? Principle of original horizontality. So then Nicholas Steno examined outcrops and observed that the bedding of the rocks was not horizontal, right? He recognized bedding of the rocks was not horizontal. So he recognized these rocks were deformed, right? What is he recognized? He observed that the bedding of the rock was not horizontal. So these rocks were deformed, right? So this is the 17th century, right? So now, after this 17th century, during the late 18th century and through the 19th century, the geological discovery have been quickened, right? Just wait. Right? Right. So, the rapid growth of geological discoveries in the late 18th century and throughout the 19th century happened due to several important reasons. So, what are the reasons why it quickened? So, because the main reasons are industrial revolution and also huge demand for coal, iron, metals, and building materials increased. So this encouraged detailed study of rock, minerals, and underground resources. This is the one main reason, and also it improved scientist instruments. So better field tools, maps, compasses, and microscopes and the chemical testing methods help geologists study rocks more accurately, and also development of geological mapping, and the scientist is William Smith and also other early geologists started preparing which one geological maps which revolve revolutionized the understanding of rock layers and also structures, and also advancement in fossil studies. So those are called paleontology, right? So study of fossil is called paleontology, and also fossils began to be used for identifying and correlating rock layers, helping in understanding earth history, and also growth of scientific scientists and geological societies. So those are Geological Society of London and founded in 1807, promoted research and collaboration and also publication, and improvement in transportation and roads, railways, ships, and those are improved, allowing geologists to travel further and explore new regions, and also emergence of geological theories. And last one is concepts like uniformitarianism. So this principle is developed by James Hutton and Charles Lyell. And stratigraphy and age of the earth created a scientific basis for geological studies. So these are the main reasons for what. So the geological discovery have been quickened. Why? Because these are the main reasons, right? So now in 1785, the scientist James Hutton introduces the doctrine of uniformitarianism. So this is very important, uniformitarianism. So what is this meaning? So that is the present. Remember, the present is key to the past. So present is the key to the future anamata. Future means past, right? Uh, Sorry, past means back, not future. So present is key to the past, right? So uh, plus a group of scientists started to recognize themselves as geologists. So their main aims, what are their main aims? To make geological maps and reported the formation of rocks and the origins of specific structures in mountain ranges, and later ideas about the origin of mountains have evolved gradually. So this is the very important uniformitarianism. So this is introduced, who introduced? James Hutton in the year of 1785. Okay. Now, firstly, they believed, those scientists, right? They believed that movement of magma upward generated mountains and the associated faults were generated by downslope movement along the flanks of these mountains. You see, these are the, right? These are the faults. So now subsequently, the horizontal forces were emphasized and the scientists were believed that mountain ranges evolved due to contraction of the earth. So that resulted from the progressive cooling, right? So the later James Hall recognized that the Paleozoic strata in the Appalachian in North America. So they were much thicker than correlative strata in the interior of the continent. So this led to the development of geosyncline theory, right? So where deep subsiding and a sedimentary basin evolved into mountain range, right? So after the 18th and 19th century, so in the 20th century, the foundations of structural geology solidified. But by the 1960s, it became a real science by the formulation of plate tectonics theory. It's called plate tectonic theory. This is also very important and they consider as a revolution in earth sciences. So this is the very important plate tectonics theory. And now we are going to mechanical principles and field procedure. So now what is the structural geology? What is the meaning of structural geology? Structural geology is the study of the structural, what is that? Features, right? Structural features of the rocks, right? Or it is the study of the three-dimensional distribution of rock units with the respect to their deformation history, right? So that the structural features of the rocks, their geographic distribution and their causes. So in the scientist right? Building, not building, billing, Billing. So he defines, right? He defines structural geology as the study of architecture of the earth crust, right? As it has resulted from deformation, right? Deformation. So the expression architecture of the earth crust is very appropriate because structural geology aims at understanding and interpreting, right? Interpreting the form, summary, geometry, and certainly the elegance and artistic assembling of the components of the earth crust on all scales. So the geologists are concerned with structural features which range in from size from those observed in an outcrop, that is it's called megascopic, right? So to those of regional size which are to be represented on geological or structural maps. So the some of the features of a still large scale are considered in tectonics, right? I already told. So, which is the study of the features of much broader or larger components of the earth and their causes. So, the primary goal of the structural geology is to, what is that? To use measurements of rock to uncover information about the history of deformation. It's called strain and in the rocks. So, and ultimately to understand the stress that resulted in the observed stress, strain and geometrics, right? So now this understanding of the stress field can be linked to important events in the regional geological past. A common goal is to understand what is the structural evolution of a particular area with respect to regionally widespread patterns of rock deformation. Examples, mountain buildings, rifting. That is due to plate tectonics, right? Plate tectonics. So now, first, what is the objectives and methods of structural geology? Anybody? So now, objectives. Object means the structural geology is the primarily concerned with the recognition, representation, and also genetic interpretation of rock structures. So first of all it is necessary to study the rock bodies and the determine their shapes, sizes, and structural characteristics. So does the rock body consist of flat lying tabular with the folds have a wavelength of several kilometers, right? Several kilometers and an amplitude of thousands of meters, or does it represent a huge block of this earth crust that has moved several kilometers from its original position? Such and other questions can be answered only by detailed, right? Some detailed investigations of the rock bodies concerned, right? So the geological field work therefore form the first and the most indispensable part of the study of the rock structure, right? So now what is the job of the structural geologist? What? So it means the geologist do measure rock geometries and also they reconstruct their deformational histories and also they do calculate the stress field that resulted in that deformation. So these are the important things the geologists are doing these ones. So in structural geology, the stress is the force per unit area acting on rocks. So for example, compression and tension and also shear from tectonic forces. So while strain is the resulting deformation, it means the change in shape or size or volume, right? So the resulting deformation, the rock undergoes measured geometrically as ellipses or ellipsoids. So the rocks deform in different ways. Different ways means that is brittle fracturing or ductiling folding. So these are the examples. It is depending on stress type, intensity, and also temperature and composition with stress causing strain. And the study of their relationship revealing Earth's deformational history. Right? Now, what is the stress and strain? Now, you see, what is the definition of stress? The internal forces per unit area acting on a rock body. So this is the rock. So this is the internal, what is that? Force, right? Internal force per unit area. So acting on the this rock body. This is called stress. So what is the types? The compression and also tension, shear, lithostatic. I will tell you briefly. So types compression means pushing force is causing rocks to shorten folds, and tension is the here, and shear and lithostatic. So I will tell the briefly. And strain means the resulting change in shape, volume, and orientation or position of a rock. So that is called strain. So here also types of deformation is there: elastic, ductile, brittle, right? So I will tell. Now you see types of stress. So now what is the stress? That is, imagine a vertical, right? Vertical column of material, that is called stress along any imaginary horizontal plane. So within this column, the material above the plane, because of its weight pushes, right? Its weight, this pushes downward on the material below the plane. So similarly, the part of the column below the plane here, the pushes upward with an equal force on the material above the plane. So the mutual action and reaction along a surface constitutes a stress, right? So moreover, along any imaginary plane with the column, there are similar actions and reactions is there. The imaginary plane may be horizontal or vertical or inclined, right? Or inclined at any angle, right? At any angle. So the force due to the weight, right? This weight of the part of the column that lies above the plane and acts in a vertical direction. So this force would be directed normally to horizontal plane. So along an inclined plane, however, the vertical directed force would be resolved into a normal component and a tangential component, right? So that normal component is a compressive, right? Compressive. So compressive stress. It's called compressive stress. So if it tends to push together the material on opposite side, this opposite side, right? Opposite sides of the plane. So the normal component is a tensile stress, right? You see here. So this is the compressional stress. What is this compressional stress? The normal component is a compressive stress, right? So if it is tends to push together the here you see here, push together the material on opposite sides of this plane, right? So the normal component is a tensile stress. This is called tensile stress. So if it tends to pull apart the material on opposite sides of the plane. So the tangential component is generally called a shear stress or shear, right? So this is the difference between these types of differential stress. This is tensional stress and compressed stress and shear stress, right? So physically, the measurements, right, measures the stress as the force per unit, right? Force per unit area, right? So it is stated in pounds per square in tons per square foot. So square foot, kilograms per square centimeters or similar convenient units, right? So some of the engineers prefer to use this unit stress force per unit area, right? We also prefer this unit only, right? So it is essential to distinguish between the external force that is applied to a body and the resulting internal action and reactions that constitute this stress, right? So use some of the pictures here. This is also tensional stress, shear stress, right? So how to this calculate of this stress? So that means there is a no direct way, right? That is to measure stress in a rock body. So, but they may be calculated. How? If the external forces are known, if a body is compressed or stretched, right? So the stress is referred to a plane perpendicular to the direction in which the external forces area acting. So thus, if a vertical square column 10 inches, 10 inches on a side support, right? A load of 5,000, right? 5,000 um, pounds. So every this horizontal plane in the column is subjected to a compressive force of this 5,000 pounds if we neglect the weight of the column itself, right? So each square inch of these horizontal planes support a load of 50 50 pounds per square inch. 50 pounds for square inch. So the compressive stress is said to be this 50 pounds per square inch if a vertical rod with a cross-sectional or of 10 square inches carries a weight of this 5,000 pounds at its lower end. So every horizontal plane in the rod is subjected to a pull of 500 pounds per square inch. So the tensile stress is said to be 500 pounds per square inch, right? This is stress and also strain. So strain is the deformation caused by the stress. Strain may be dilation, right? So which is a change in volume or distortion. So which is a change in form or both. So where there is a change in the confining pressure and isotropic body, that is a body whose mechanical properties are uniform in all directions. It will change in volume but not in shape. So with increase in confining pressure, the volume of the body decreases and the dilation is negative. So with decreasing confining pressure, the volume of the body increase and the dilation is, what is that? Positive automatically. Right? So now we are going to deformation. Right? Deformation. What is the deformation? The three stages of deformations is here. First one is elastic, second one is ductile, and third one is brittle. Right? So, if the body is subjected to directed forces, just wait 1 second. Okay, right. So that body is subjected to directed forces, right? Directed forces lasting over a short period of time, minutes or hours. It usually passes through these three deformations, right? These three deformations. Although in this brittle, right, this brittle substances, the intermediate stage may be omitted. So at first the deformation is elastic one, right? Elastic. So that is, if the stress is the withdrawn, the body returns to its original shape and size, right? Original shape and size. So there is always a limiting stress. So that is called the elastic limit. So if this is exceeded, the body does not, what will happen? The body does not return to its original shape. Return to its original shape. Right? So this below the this elastic limit, the deformation obeys Hooke's law. H, sorry, Hooks Hooke's law. So which states that strain is proportional to which one? Stress, right? So this is the elastic deformation. So this is the important question in your examination. They are asking, write about the three stages of deformation, right? So you can write elastic, ductile, brittle, right? So now, if the stress exceeded the elastic limit, the deformation is called plastic or ductile, right? Plastic. So that is the specimen only partially return to its which shape? This original shape, right? Original shape. Even if the stress is removed, stress is removed. So the steel rods under tension of example begin to get thinner or neck in the middle, and even after the stress is revealed, the constriction remain in the rod. So when there is a continued increases in the stress, one or more fractures develop and the specimen eventually fails by rupture. Rupture. This is the ductile. And third one is brittle. Brittle means permanent and rock breaks. It means the substances are those that rupture before any significant deformation plastic deformation it takes place, right? So these ductile substances are those that undergo a large plastic deformation before rupture, so that is called brittle deformation. So after the this clastic, elastic, plastic, brittle means clastic. So clastic limit has been exceeded. The ductile substances undergo a long interval of plastic deformation, and in some instances they may never rupture, right? So So these are the three. First one is elastic. Elastic mean room temperature and pressure and under stress applied for a short period of time. That is the most rocks are brittle, right? Most rocks are brittle. So they believe elastically until they fail by rupture. So for such rocks, the elastic limit or yield points is the stress at rupture. So ideally, an elastic substances will return to the original shape after the deforming stress. It has been removed. Although there may be a slight delay as unloading occurs. The elastic deformation is primarily of importance in analyzing tidal deformation of the solid earth and in investigating the transmission of seismic waves. So through the earth. So if we, it is of even more direct significance to structural geology in studying this elastic rebound associated with earthquakes. So, in the fracturing of rocks to produce the joining and falls, sorry, joints and falls, and in certain aspects of folding. So, although most of the structural features observed by the structural geologists are the result of this deformation beyond the elastic limit. The same parameters of length, mass, time, and also force. So those are involved in there, right? You see the difference between the figures: brittle, ductile. Next one is elastic. This one, elastic. You see the difference between this one, these three. The three stages of deformation, right? So you see, I wrote here something. So elastic deformation, that is material returns to its original shape after stress is removed. Example is rubber band, right? So this is the important example, easy example, rubber band, right? And elastic limit, that is point beyond which permanent deformation occurs. So this is the elastic deformation, and ductile is the permanent change in shape by bending or bending or folding, right? Sorry, flowing. So example is copper wire. And brittle deformation in the permanent change. What is that brittle information? Deformation? Permanent change in shape. So when the material fractures or cracks. So that is called brittle deformation. Example is breaking a piece of slate. Okay. Now you see, so how to measure deformation in the rock? So that is strike and dip. So these are the very, very important in your structural geology, right? So structural elements means that there are many major and minor structures and many different types occurs in nature, right? So in order to make a complete descriptive analysis of the structure, it is necessary to identify and describe the concerned structural element. So the structural element are the physical or geometrical components of the structures. So the physical elements are real and visible in their shape, size, and also orientations can be measured. So the geometric element, on the other hand, are imaginary lines and surfaces which are invisible, but it can be identified in the field, right? They too have shapes, sizes, and orientations which are measurables, right? So now the describing the physical and geometric elements measurements are required to be made for future, some of which are linear and other planar. So all these linear geological features like the grooves on fall surface are lineatic are called linear elements, right? And bedding planes and also joints and false planes, dikes, etc. So these are the come under this planar elements. So one basic element that is indispensable for measuring orientations of structures in the field, that is the compass clinometer, right? Compass clinometer. So this is used for measuring, right? Measuring trend and inclination of structural elements. So the trend refers to the azimuth, A Z U Z I MUTHOR. Azimuth or bearing of a line. Azimuth means it is a measured in degree clockwise from which one? North, right? North. This is north. North, south, east, west. Right? Sorry, east, west. So that is bearing is measured in degrees, east or west, from north or south. That is from north means 100 degrees, or south means example north 55 degrees east and south 25 degrees west. So that is the degrees between an um, inclined line or plane and the horizontal. So it is value may vary from 0 to 0 to 0 degrees to how much? 90 degrees. So the trends are measured with the compass, right? This clinometer compass and inclinations with the clinometer, which is located inside the compass. So the orientation of a linear elements in space that is expressed in terms of trend and plunge. The larger being a measure of inclination. So while this trend is measured in this horizontal plane, the plunge is measured in a vertical vertical plane containing the line. So this plunge is the angle, right? Angle between the line and the horizontal in the vertical plane. So the orientation of this planar features is given by measuring the orientation of two lines in the plane is determined by two lines. So any these two lines which are not parallel, it can be chosen. So for convenience, these two uh, lines in a plane, one a horizontal line and the other line at right angle, right? Right angle to it are chosen strike and this dip, strike and dip. So the first is called the line is called strike, and the second line of the of this rock is called dip, right? So now we are going to now dip and strike, right? You see here, it means dip means you see this is called strike. So this yellow this. So this is the rock structure. So now how to measure in dip and strike in field. So the compass is taking from this side, downside, it will call dip, and compass is taking measurements from this side, that is called strike. So dip means slope or inclination. It means slope or inclination. It's called dip. So the angle of inclination of a bedding plane with the horizontal plane is called dip amount or amount of dip, right? The direction along which the inclination of the bedding plane it occurs is called dip direction. So dip is expressed, sorry, both, right? Both as amount and direction. The direction angle is measured with clinometer. This is called compass, right? The direction is measured with the compass. Okay, this is dip and this is strike. So how to identify strike? Strike identified as the direction of a line formed by the intersection of a bedding plane and this horizontal plane. So this is the compass, you see. Okay, so it always right angle with the true dip direction. So it is a horizontal line on a surface um, of rock beds, right? Right. So according to direction, the dip is divided into two types, true dip and apparent dip. True dip and apparent dip. So now, what is true dip? You see here, true dip. What is the true dip is when the dip of a of layer is measured in a direction that is essentially at right angle. Right angle means 90 degrees to the strike of that particular layer. So that is called true dip, right? And apparent dip means when the dip of layer is measured in true dip in a direction, only one direction. Here, measured in any other directions, right? Any other directions. So this is the difference between true dip and apparent dip. So which is not at right angle. So this is essentially at right angle. So this is not at right angle 90 degrees to its strike direction. That is called apparent dip, right? So this is a one direction and this is right angle, essentially right angle, and apparent is a any other direction which is not a right angle. So that is called true and apparent dip. You see here, these are the pictures. So this is the two pictures. These are the two pictures here. Okay. This is the apparent direction and this is the true direction. Okay. So now the main principles and concepts of this structural geology, that is the original horizontality and uniformitarianism. I already told about this one. These are the very important topics, right? James Hutton. What is this principle? So present. The present is key to the past. Present is key to the past. So now the tectonics versus structural geology. What? So these both are concerned with the reconstruction of the motions that shape the outer layer of earth. Outer layer of the earth. So these tectonics and structural geology deals with the motion and deformation in the earth crust and upper mantle, right? So in earth crust and upper mantle. So the tectonic events at all scales produce deformation structures. Which one? Tectonic events. So these two means tectonics and structural geology. These two disciplines are closely related and interdependent. So these are the very important. Now you see the definitions of these two. First one is tectonics. What is this tectonics? The study of the origin and geologic evolution. Geologic evolution means history of motion and deformation. So the geologic evolution of large areas, those are regional to global. That is called large areas of the earth lithosphere. Lithosphere means origin of continents and buildings of mountains, belts and formation of ocean floors. So this is the tectonics. Now, structural geology means study of deformation in rocks at scales ranging from submicroscopic to regional. Regional means here you see micro, meso and macro scales, right? These are the definitions of those. So now use of models. Now we use geometric mechanic and kinematic models to understand deformation on all scales. All scales means micro, meso and macro levels. So, and geometric models. Geometric models means 3D interpretation of the distribution and orientation of features within the earth crust. So these are the geometric models. And the kinematic models means a specific history of motion that could have carried the system from an and deformed to its deformed state. So that is the kinematic model. Example, next one is plate, right? Plate tectonic model is the kinematic model. This is the example. Okay. Now, mechanical model is the based on laws of continuum mechanisms. So, what is this one? Study of rock deformation under applied forces and a model of driving forces of plate tectonic based on the mechanics of convection in the mantle. That is a mechanical model. Now, what is the analysis of these models? That is descriptive means recognize, describe structures by measuring their locations and geometries and orientations. And break a structure into structural elements and physical and geometric. And kinematic model is interpret. How to analysis these kinematic means it interpret deformational movements that formed the structures. What is the structures? Translation, rotation, distortion, and dilation. So these are the structures. And dynamic model analysis is interprets forces and stresses from interpreted deformational movements of structures. Now, what is the structure? Structure is a geometric feature in a rock whose shape, form, and distribution can be described. So, this is the structure and microstructure. Microstructures mean microstructures of the igneous rocks. So it means the small scale arrangement, right? Small scale arrangement of geometric and mineralogical elements within a within a rock. That is called microstructures. And textures. Textures of the rocks means it preferred orientation of crystallographic axis in the sample. This is called texture. So this is structure and this is texture. And microfabric means it comprises the microstructure and the texture of a material. So that is called microfabric. So now in next class I am saying, so these are the fundamentals of the structures of rock. So those are primary structures is there and secondary structures is there. In that fractures means joints and shear fractures and also vein and faults and folds. So these are the very important fundamentals. So what is the structural geology? It is the study of the factors such as or occurrence, classification, type and effects of various secondary structures like folds, falls, joints and rack cleavage. So, and those are different from those primary structures such as bedding and vesicular structures. So, which develop in rocks at the time of their formation. Right? So, up to here, now over. Okay. So, I will tell the next class in false, false, giants, and also unconformities is there. Okay. So these three stages of deformation is are very important. This is in your examination they're asking. This is very important question. Okay. So all structures is also very important. Falls, folds, giant structures. Those structures are very important in your theory examination. Okay. Okay.